activity 4. We're going to learn how to use our calculator to create histograms, making our life a lot easier, right? So activity 4 has a new set of data for us. Where's the thing? Consider the collection of quiz scores from a statistics class. So here's a bunch of data points. These are quiz scores from, guys, can we keep it down? These are the different quiz scores from some course. So somebody got a 74%, somebody got an 89%, and so on and so forth. So we want to create a histogram with these. So let's go to our calculator, input these data points. So let's go back to our calculator. Now I don't want to erase the information from the previous activity of having the ages of the actors and actresses. Let's leave that in there so that we can come back and then redo that with our calculators as well. So let's go over to, say, L3, a new blank one, and I'm going to input these quiz scores onto L3. So 74. Okay, good. So we inputted all our data into L3. So now let's use that information to create a histogram. So the first thing we want to do is quit. Get out of here. Let's go back to our main screen. So I'm going to hit second so that when I hit mode, I'm really selecting quit. So let's quit out of here. Keep in mind that I put all my data on L3. Now I want to go over to y equals. Right up here, y equals. This is where you input equations. See, there's a bunch of equations from an old situation that the calculator just remembers. This might cause problems. So we want to get rid of these equations. We don't want them. To get rid of them, you can hit clear, and it'll just erase them. Go down and clear the rest. Clear, clear, clear. So go all the way down. Now there's some hidden down here. So go to y sub 8, y sub 9. Make sure there's nothing down there. All of it is just clear. We don't need it. Okay? Good there? Okay, next we're going to go to stat plot. It's above y equals, and it's in blue. So we got to hit second, that arrow appears, and now we hit stat plot, and we get to this screen. Okay? From this screen, we'll see the 3 different plots that we can graph at the same time. This is kind of an overview of those plots. So I'm just going to go into the very first one. You can use your arrows to select which one you want. So I'm just going to go into the very first one, hit enter. And then I'm going to choose to turn it on. You can use your arrows, go left and right to select things. Hit enter to turn it on. Go down. And now it says, what type of a graph would you like? And for us, we want this one. We want a histogram, right? Looks like this. So we got to use our arrows to go over and select it. Select it, hit enter. Okay, and when you select it, the choices down here change because depending on what kind of thing you want to graph, the options change. And so for me, if you recall, we put all our new information onto L3. So let's select second L3. L3 is right above the number 3, and it's in blue. So I had to hit the second mode function, and then this little arrow appears. And then I hit 3, and it'll say L3. Leave frequency as 1 for now. We'll talk about how that changes in a second. But let's leave it alone as 1. So now we're set. Now let's go back to stat plot. Heckin' stat plot. So now you can see that now I have a little overview of what's happening. Plot 1 is on. I've selected histograms. It's got these little bars. The data is located on list number 3. And frequency is stated as a 1. So this gives you a little overview of everything that was going on with plot 1. And for plot 2 and plot 3, we notice that they're off. And that's what we want right now. Okay? So if they are on your own calculator, somebody had them on before, then you need to go in here, so go into one of them and select off to turn it off. Off. And then you can go back to the main screen and see that only plot 1 is on. It's a histogram on L3, and the frequency is 1, and that plot 2 and plot 3 are both off. Okay? Good, 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 good. Any questions so far? Okay, so next we want to be able to choose the window. So we'll go over where it says window, and then it gives you some options. So for now, let's just copy what the worksheet tells us to do, and then we'll talk about what they mean. So the worksheet, activity 4, gives you this window. Values of 0, 100, 10, 0. Okay, so let's just input those into here. So 0 for x minimum, 100 for x maximum, scale, x scale of 10, y minimum of 0, y maximum of 10, and y scale of 5, and then x resolution of 1, and you can just leave that like that. So we input all those values into there, and we finish inputting all those values. We're going to go over here where it says graph. So we hit graph, and we get something that looks like that. Okay, so let's explore what these numbers mean. This x minimum is letting you know that this is a 0 right in here. Right? Not all, it doesn't always have to start at 0, so the different data points might have a different starting point, but here we've chosen to start our histogram at 0, and x maximum as 100 means that this point over here is 100. Okay, so it's ranging from 0 to 100, and then the x scale means that each one of these classes has a width of 10. So this is going from 0 to 10, right, 10 to 20, 30 to 40, right, so on and so forth, counting all the way up to 100. And now in this direction, it is the frequency, and it's going from 0 to 10, so this is 0 here, and this is 10 up there, and it's counting in multiples of 5. So that means that this little tick mark here is going from 0, 5, 10. Good, good, good. So most of the time we like to use 1. I think that's appropriate in this case. So let's, for instance, go back to window and change the y scale to 1, and we'll see how that affects things. Hit 1, enter, and then graph. And now we have a bunch of tick marks this way. So now it's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it's counting multiples of 1. In this direction, it's counting in multiples of 10. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Good? So that's what the y scale and the x scale tell you. With these little tick marks, do they count in multiples of 1, of 5s, of 10s? Good? Let's go back one more time. Let's change y scale to 2, and it's going to count in multiples of 2. So now this means 2, 4, 6, 8, 10. Good? All right, so this is letting me know that between 0 and 10, there were no values. There are nobody got a quiz score of 0 to 10. From 10 to 20, it looks like one person got that score. Here it looks like one person got the score of between what? 20 to 30. Somebody got a score in the teens. Somebody got a score in the 20s. How many people got a score in the 30s? Well, it's hard to tell. Is that a 2 or is that a 3? What do you guys get out of it? Kind of hard to tell a little bit, right? Okay, so in order to improve the way we read this, we can hit this button that says trace. And now here's where the problem comes in. Just for a second, move this arrow and go to the right. Let's go a couple of places. See that little blinking cursor? That's letting you know the center of that box. This is telling you that that box is between 40 and 50, and it's letting you know that it's got a height of 3. So there were 3 students who got a score of between 40 and 50. But for the first few classes, it got overlapped, right? So it's kind of hard to tell what's on there. For that reason, let's go back to our window and extend our y minimum below 0 so that we can create a little bit of a gap and have enough space for this to be read. Okay, so let's go back to window and let's go to y minimum. And instead of starting at y minimum of 0, let's start it at like negative, I don't know, how about negative 5? Let's see what that looks like. Graph. See how this goes all the way down to negative 5 now? So it's scooted up everything to there. that might be a little bit too much. So let's go to window again. Let's make it -4, -3. How about -3? Graph. Okay, so it gives you a little bit of a nice space there in blank. And now when I hit trace, yeah, perfect. Now there's enough room there so that I can see what I'm doing. Okay, so now that little blinking cursor, for the first class, there's nobody that landed between 0 and 10, 0 values. And then if I go to the right, between 10 and 20, one person got a score between 10 and 20. One person got a score between 20 and 30. Looks like 2 people got a score between 30 and 40, 3 between 40 and 50, 3 between 50 and 60, 3 between 60 and 70, 5 between 70 and 80, 5 between 80 and 90, and 2 people got a score between 90 and 100. Any questions so far? Yeah. So, like, why does it have an inequality here? Because what if someone got exactly a score of 90, exactly 90? Which box do they belong in? Do they belong in this box or do they belong in this box? So they're just clarifying that if it's exactly a score of 90, they don't fall in this box, they fall into the one where it's starting at 90 and up to and less than 100. Okay, so we're pretty clear on how to choose these things. Let's go back to window. What if I wanted to use less classes? What would I do to change that? What if I only wanted to use 5 classes instead of 10?
You go down to X, C,
And increase my scale to what?
5.
Increase it to 5? That would give me 5 classes? No. Remember, this is the class width, and I'm going from 0 to 100. So we just count in multiples of 5, 0, 5, 10, 15, 20, 25, 30. So it ended up giving me 20 classes, right? Let's just graph it right now. You can see what it is. See, we end up getting lots of little boxes, right? All of these guys. Let me make this big. We end up getting lots of classes because this is going from 0, 5, 10, 15, 20, 25, 30, 35. And again, there's nothing wrong with this. We want to come up with the right number of classes to present our data and see if there are any patterns.
And you want 5 classes, so you go to
Correct. So let's go back to this window, and instead of choosing 5 classes, let's choose the class width to be 20. That'll guarantee that we have a total of 5 classes. So now we have 5. 1, 2, 3, 4, 5. 5 bins, 5 classes. And this is ranging from 0 through 20, 20 through 40, 40 through 60, 60 through 80, 80 through 100. Good? Questions, comments, issues, questions? No? And again, if you wanted to find better information as to how tall is this, how many values are in this rectangle, we can hit trace and then use our cursor to go to the right. There it is. So now it's easy to tell that I have 8 values, right? Histograms are not always the best way to give the exact numbers, right? The fact that it's a height of 8. Histograms are a great way of describing the shape of the data and where the data is clumped up. So it's not always necessary or important to know the exact number. And often when a histogram is given to you, you're not really able to tell the exact number, but you can get a pretty good idea of sort of where the number lands. And it also gives you an idea of the shape of the data. Good? Sort of, kind of? Okay, now let's go back and do the same thing with the information from the previous activity where we had all the actresses and actors. That was on L1, right? So let's go back to stat plot. Let's go in here. And let's go and select L1, which was the actresses, L1. So now it's going to take the data from the actresses to create our histograms. And let's go back to window and adjust this a little bit so that it makes sense. First of all, we don't have to start at 0. We said that the youngest actress was like 21. So we can start at 21. And the max was 80, right? And we can make this 10 for the class width. And okay, let's graph it right now, and I think you'll see that there's a problem. What went wrong? The y maximum, right? Look, it's set, right now it was set to y max of 10, but some of these classes have a lot more actresses fall into those bins than 10, right? When you did it by hand, what was the largest number that you got, frequency-wise? 29. There was a case where like 28 or 29 actresses landed in one. So we want our y maximum to be large enough to capture that. So why not extend that out to say 30? Graph. See, now it's tall enough to capture the tallest one on here. Good. I don't know if there's going to be enough room now for us to be able to do the trace thing. Yeah, it's kind of ugly. Now it overlaps it again. So just for the purpose of making room for that, let's go back to window and change things just a little bit. Let's make y minimum, let's say, how about negative, let's make it -8, see how that does. And let's make this 35. Actually, let's make this 35 and let's just go ahead and make this -10. This is just guessing and checking. No perfect science to this. Okay, so now it looks like that. And if I hit trace, there's enough room for me to be able to tell which is which. So I can tell that for the actresses, there were 28 actresses whose ages landed between 21 and strictly less than 31. So remember, strictly less than, since there are no decimal values, the biggest number that's going to fall in this box is going to be 30, right? 31 is going to land in this box. Good. So now we go to the right. And so between 31 and 41, there were 30. Between 41 and 51, there were 12. And then very few after that, right? So not too many actresses above 50 ever gets the award. Any questions? Any questions? Okay, now let's do the same thing for the males. Makes it easy to go back and forth now, right? So let's go back to second stat plot, enter, and we can just change this to L2. That's where the male information was, and hit graph. And this was the male's information. If you have one of the nicer TI-84s that have color, then when you can do them both at the same time, they overlap and they're in different colors, so it looks really nice. I'm going to do it here, but it's going to look ugly. So here we have the male data. As we can see, there's a lot more males that got the award when they were a little older, right? Not as many in the young. Remember how many? There was a lot of women that got their award in the 20s and 30s, right? I think it was like 28 and 30 were the two. For males, there's very few males. Only 3 males have ever gotten their award in their 20s. Only 24 have gotten them in their 30s. The bulk of them, the majority of them have gotten them in their 40s, 41 to 51. And then a lot more of them have gotten them above 50. Right? For the women, there are very few above 50. For the males, there's quite a few that are above 50. Good. So we can overlap it by doing this. Let's go back to stat plot. And let's go back to plot number 2 now. Since plot 1 is now the males, let's go to plot 2 and turn it on. And then we can go and select histograms. And then that's the women right there. So now if we go back to stat plot, we can see an overview. Now plot 1 is on. It's a histogram. L2 is the source of the data. That's the males. 1 is the frequency. Plot 2 on histogram. This is the women, the data for the women, and also frequency. So now I can hit graph, and it'll do both of them. But it looks terrible because it's hard to tell which one is which. So again, if you have the colored one, it makes it nice. One of them will be red, one of them will be blue, or something like that. So it doesn't look that great for us. It would be better to toggle back and forth between one and the other rather than doing this. So to toggle back and forth, to turn them on and off quickly, a nice easy button for that is this over here. So go back to y equals. See up here how plot 1 and plot 2 and plot 3 are up here? The fact that plot 1 and plot 2 are dark means that they're both on, they're active. Right now I have them both on. And an easy way to just turn them on and off is to select it with your arrows and hit enter and see if you move away from it. Now it's been deactivated. So now if I go hit graph, it's only plot 2. Right? This was the actresses. And again, I can hit trace if I want to know the exact values of these things. Or I can go back to y equals, go up here, turn on the plot 1, turn off plot 2, and go back to graph. And now this was the male actors. So it just makes it a little easier to go back and forth between turning them on and turning them off to be able to read the information. Okay. So again, you can hit trace and get some more information of the data points. Good. Keep in mind that for your tests, I often like to take screenshots of stuff like this. So I might take like a screenshot of this and ask you to give me information like how tall are the rectangles, how many total people are there, stuff like that. Things that you would be able to tell by understanding what these histograms are telling you. So if I also included like the height or the numbers or gave you some information about what these little tick marks mean, you might be able to recreate or be able to tell me what's the total number of actors that have gotten their awards at this point. Or if the numbers were kind of written at the top of each rectangle, you would know to add them all together to be able to tell the total number of actors that have gotten their awards. Or I might ask you some other thing. Maybe create the frequency histogram from the relative frequency histogram, or the other way around. Given the relative frequency histogram, find the frequency distribution, stuff like that. Any questions? No. Okay, so let's go back to activity 4. Okay, remember we were working with these quizzes. So here are a bunch of quizzes, 26 of them. We put them all onto list 3, and then we were able to create our histogram that looked kind of like that, and we were able to distribute it. Sometimes you're given a long list of random numbers and you want to create a histogram. That's one option. The other option might be that the data has already been grouped for you. So say, for example, this. Here is data from Old Faithful Geyser in Yellowstone Park. The given frequency distribution summarizes a sample of times. So this isn't the actual numerical times. This has already been put together into a table. I know there were 8 values that landed between 40 and 49. There were 44 values that landed between 50 and 59, right? There, so on and so forth. So how do we put this information into a calculator to create a histogram from grouped data? That's the other option. So what we're going to do is we're going to find the class midpoints for each one of these. So add these two things together and divide by 2 is one way to find it. Some authors like to go from this way, so 40 and 50, you add them and divide by 2. Either one is fine, I will accept either one, but it looks like that's what they did here. So 40 plus 50 is 90, divided by 2 is 45. And 50 plus 60 is 110, divided by 2, that's 55. Okay, so I will accept either one. I think our author likes to do it the other way around. So 40 plus 49 is 89, divided by 2 would be 44.5. Okay, so either way you do it is fine. Come up with your class midpoints. So now we have a new list here where we have class midpoints and we have frequencies. Now we're going to go to our calculator and we're going to input these values. Okay, so let's go back to stat, edit. And now, okay, again, I don't want to erase those. I might use those down the road. So I'm going to scoot on over. I think it gives us a standard of 6 lists to work with. So hit clear, enter to erase all the values underneath these other lists. We're going to use them. So I'm going to input all the midpoints onto L4. So 45, 55, 65, 75, 85, 95, and 105. And then the frequency count, 8, 44, 23, 6, 107, 11, 1. Okay. So I have them all on there. So keep track of the fact that I'm using L4 and L5 now. On your worksheet, they put things on L1 and L2. It doesn't matter. You just keep track of where you put your information. So for me, L4 was the midpoints, the horizontal values, and the frequency is the L5, L4, L5. Okay, so I'm going to go back to stat plot, second stat plot, and I'm going to turn it on. So go in there, turn it on. I've selected histograms. I said that the data points are on L4. That's going to be the horizontal values, right? The X list. And then the frequency is going to be L5. That's the difference between the two. If you just have the actual original data points, just one big long list, then you leave frequency as a 1, and then you put where your list is up on X list. On the other hand, if you're dealing with grouped data, then you have to put it this way. So L4 was where all my class midpoints were located, and L5 was the frequency of those values. Good? Okay, so now we can go back to window, and I think we're going to have to change these values a little bit. Okay, so now we got to go over to window, and they give you a window for you to initially try. You know, once we put this in there, we'll look at what these numbers mean. And then later on, you're going to have to make these kinds of decisions on your own. So X min 45, X max 115, X scale of 10, Y minimum of -20, -20. By the way, this is negative down here, so don't interchange it with this. This is subtraction. So here's a -20. This would be subtraction of 20. And if you use the wrong button, it'll give you an error. So X max is 110, and Y scale is 10, and let's just leave that as a 1. It's hard to tell what that is in there, but that's fine. Hit graph, and you get this, which looks a lot like the one from the activity. And you can also go back over here and hit trace and be able to tell where those guys are. Any questions? Any questions? Any questions? Any questions? No? So looking at their choices for the window, right? X going from 45 to 115 lets us know that this is ranging from 45 to 115 over there. And this ranges from -20, and they just went down into the negatives to make a little bit of space for us to be able to see this when we hit the trace button, all the way up to Y maximum of 110. So this tall one up here has enough room to be on there. Any questions? Any questions? Any questions? No? No? Okay, so those are the two options that we deal with when we want to create histograms. Either we have the original data. Let's go back to this thing over here. So here we had the quiz information, right? We know the actual quiz scores. Someone got an 89. Someone got a 91. We have the original data that's been untampered, not grouped. It's ungrouped raw data, the actual data points. So we put them all onto a list, and then when we create the histogram, we need to select 1 as the frequency. So that would be this. We come over here. We hit L1, L3 is where all the information is, and then this guy is a 1. So leave it as a 1. Right? That's for raw data. On the other hand, if we don't know the original data, it's just presented to us that has already been grouped in a way that has already been grouped. See, we don't really know what the actual scores are. We just know that there are 8 of them that landed in this class, and there are 44 of them that landed in this class. A class where the midpoint is 45, the midpoint is 55, and so on and so forth. Good? So when they're grouped this way, the information is grouped, then we really have a little bit less information, right? Because we don't know the actual numbers. I know there was 107 of them that landed in this class, but I don't know the actual numbers. So in order to create a histogram from group data, then we go over to StatPlot, enter, and then we input both where the midpoints are located, L4 in my case, and L5 for the frequency results.